Hello everyone. Today I am going to discuss one very popular method of numerical analysis, that is Runge-Kutta method. We are going to discuss here Runge-Kutta method of fourth order. It is actually a numerical technique to solve ordinary differential equation with the order dy dx equals to fxy, where yx0 equals to y0, right? And we have to find xn is any value, okay, of x. Now as we know from the previous videos that there is a step function or step difference that is called h. H is actually x I plus 1 minus xi, that is the difference between two consecutive instances of x, or we can say from this equation xi plus 1 equals to xi plus h, that is x1 equals to x0 plus h, right? Similarly x2 will be equals to x1 plus h, so x1 plus h. And as we have got x1 equals to x0 plus h, so putting the value of x1 in this equation we will get x0 plus 2h, because x1 equals to x0 plus h, so it is x0 plus 2h. Similarly x3 will become x2 plus h. There is an increase, we can say this as increase also. So x1 will be incremented by h and it will become x2 will be incremented by h and it will become x3, and so on. So x3 by this way will be x0 plus 3h, and we can get any value of like xn for by calculating this h, okay. And the value of h can be given in question, or we have to derive it, okay. We have to calculate it from the question if it is not given. Sometimes in problem it will be given in the question, or sometimes it may not be given. So in that case we have to generate the value of h by the help of the given variables, okay. Now what is Runge-Kutta method? Runge-Kutta method, as I said, it is used to solve ordinary differential equation of the form dy dx equals to fxy, and where y0 and x0 will be given, right? So here we have to use this formula. I found this one is the easiest for order 4. So what is this? It is yn plus 1 equals to yn plus 1 by 6 k1 plus 2k2 plus 2k3 plus k4, okay, where k1 equals to h f xn yn, f of xn yn, k2 equals to h f of xn, f is the function actually, xn plus h by 2, yn plus k1 by 2, k3 equals to h f of xn plus h by 2 comma yn plus k by 2, and k4 is h f of xn plus h yn plus k3, okay. It is actually xn plus h, okay. N is and the value of n we have to find out, okay. It depends on the problem. Now from this we have to put one by one according to the problem. We have to put n equals to 0, n equals to 1, n equals to 2, and so on. It depends on the problem that how many values for n we have to put one by one, okay. Now coming to a problem, we'll understand it properly and clearly and in a easier method, okay. Now using Runge-Kutta method, let us check this problem. Using Runge-Kutta method fourth order to solve the ordinary differential equation dy dx equals to xy with y1 equals to 2 at x equals to 1.2 with h equals to 0.2. Now given dy by dx equals to fxy equals to xy, right, as per the solution. So here fxy is xy, it is given. Now y1 equals to y1 equals to 2, so we can write x0 equals to 1. How we will get the value of x1? X0 equals to 1, because this is the value of x0. Okay, it is actually y0, right? Because it is of the form this yx0 equals to y0. Now for x0 equals to 1, y0 is equals to 2, right? Now h is given here in this question, so h will be equals to h is 0.2 as it is given in the question. So x1 will become x0 plus h, that is equals to 1 plus 0.2 equals to 1.2, right? So for 1.2, see, we have to find the value of y at x equals to 1.2. So y1 will be yx1, as we have got already the value of x1 as 1.2, so we have to find the y1. Y1 is y equals to y of 1.2, and that value we have to find out, right? Now by Runge-Kutta method, yn plus 1 equals to yn plus 1 by 6 k1 plus 2k2 plus 2k3 plus k4, where k1 equals to h f of xn yn, k2 equals to h f of xn plus h by 2 yn plus k2 by 2, right? And k3 equals to h f xn plus h by 2 yn plus k2 by 2, and k4 equals to h f xn plus h yn k3. Now it is not that much hard to remember from this. Actually these formulas are not that much hard to remember. If you find it, the value of k1, k2, k3 and k4, you will see k2 will be derived from the value of k1. See, it is k1 by 2. Okay, now k3 will be derived from the value of k2, and k4 will be derived from the value of k3, right? And this xn, h, these values will be given. Now putting n equals to 0 in equation 1, y1 equals to y0 plus 1 by 6 k1 plus 2k2 plus 2k3 plus k4, as we know from this equation 1, right? So it is our equation 2. Now where k1 equals to hf x0 y0, putting the value of n equals to 0, so it will become hf of x0 y0. It means h into x0 y0, as per the function it is written, it is given fxy equals to xy, so it will be f of x0 y0 will become x0 y0 x0 into y0. So putting the value of h, x0 and y0, because all these values are given in the question, x0, y0, even h. So h will become, if we calculate, h will become 0.4. Now coming to the value of k2, if we calculate, it will be equals to h f of x0 plus h by 2 comma y0 plus k1 by 2. Now these values are also given, and k1 we have just calculated, the value of k1 is 0.4. So calculating this, see, this will be treated as whole x, and this will be treated as whole y. So here xy, f of xy equals to xy, that means this whole portion into this whole portion. Okay, that will be the value of this function, f of this. So and the value of h is 0.2. So 0.2 into 1 plus 0.2 by 2, 2 plus into 2 plus 0.4 by 2. 0.4 we have got from here, right? So it will become, if we calculate, it will become 0.484. Now coming to the value of k3, it will be hf, just check, k3 is hf xn, that means x0 plus h by 2 plus yn, that means y0 plus k2 by 2. So it is x0 plus h by 2, y0 plus k2 by 2. Just like the function, previous functions, it will become, after calculation, 0.49324. Understood? Now K4. What will be the value of K4? Similarly, a similar type of thing, we have to put all the values of here, putting n equals to 0, K4 will become h, x0 plus h, y0 plus K3, right? So it is K4 equals to h x0 plus h plus comma y0 plus K3 equals to 0.2 into 1 plus 0.2 by 2 into 2 plus 0.49324 by 2 equals to 0.59834, right? So from the equation 2, you can see here, equation 2, we are putting all the values of k1, k2, k3, k4 and y0, will get y1, right? So putting all the values here, y0 is given, and these values we have already calculated. K1, K2, K3, K4 we have already calculated, so it will become this, and finally after calculation we'll get y1 equals to y 1.2 equals to 2.49214, right? If in the question it is given that we have to find out the value, the approximate value correct to 3 decimal point or 2 decimal point, then accordingly you have to take these decimal points. Like suppose you have to find out the value up to 2 decimal point, then it will become 2.49, right? And if nothing is given in the question, then whatever your answer will be, you can put it here, and that will be final answer. Okay, it is up to you how much or how many decimal point you will give here, right? So y 1.2 equals to 2.49214, and that will be our answer, right? So for your convenience, I'm just putting all these things together. You can check it out. You can take a screenshot, and it will be easier for you to understand. Hope you have understood this problem. If you have any problem or any query, please feel free to ask me in the comment section. I will try my level best to answer your queries. Thank you.